Question 9, Edexcel Pure Mathematics 1, January 2023. Question 9 shows a sketch of curve y equal tan x. So here we have y equal tan x and straight line y equal pi x. So in part A, state the period of tan x in the interval minus pi and pi. So here we have pi minus pi, and we know that the tangent function y equal tan x completes one full cycle between each set of a vertical asymptote. So the first set here of vertical asymptote at pi over 2 and minus pi over 2. So tan x completes one full cycle between each set of vertical asymptotes that are pi units apart. This means that the function repeats its values and pattern every pi unit. So the pi. So part A, the period of tan x is pi. For part B, write down the number of roots of the equation. So here we'll find how many times do they intersect. So in I here we have tan x and we have the straight line pi plus 2x in the interval x greater than minus pi less than pi. So here you can see the tan x equal pi plus 2x in the interval minus pi to pi. From minus pi to pi, here we have the intersection point. This is the first intersecting point, and here the second intersecting point, and here also the third one. So in this interval, the straight line intersect the curve tan x 3 times. Since pi over 2 minus pi over 2 equal pi over pi. So in tan x in the interval minus 2 pi to 2 pi, as you can see here we have vertical asymptote, and as you can see as well, this is the period here, period pi. So we have one cycle, and here we have the second cycle, and here we have the third cycle. So now we will continue drawing the line L. You can see this is the intersection point, and here as well, and here as well, and here, and also here. So count them 1, 2, 3, 4, 5. So we have 5 intersection points. Now tan x equal pi x in the interval minus 100 pi to 200 pi. So as you can, we can use double I part double I. 2 pi minus 2 pi, it's 4 pi divided by the periodic function pi, you will get 4. So 4 intersection point plus the one we have it in the original. So here 100 pi minus 100 pi, we'll have 200 pi over pi. So we'll have 200 intersection point plus the point, the origin, which is 1. So we have 201 intersection point. Question 10 here. Question 10, we have curve f of x. See, this is the curve f of x, and we have also a straight line which is L. We need also to work it out. So the first part here, they need from us to use the given information to state the values of f of x for which f of x greater than 0 means we need to search positive sign. So here we have function f of x. We need to figure out the roots. So the first linear factor, x equal minus 20 over 3. This is the first root. The second root, x plus 6, so x equal negative 6. This is the second root, and the last root is 2x minus 3, so x equal 3 over 2. So we can use the graph itself here. Here we have negative 20 over 3, and here we have negative 6, and here we have 3 over 2. As you can see, between negative 20 over 3 and negative 6, sign is positive above the x-axis, so the first interval x greater than or equal negative 20 over 3 and less than or equal to negative 6. The second interval here above 3 over 2, which is above the x-axis, it means positive. So here we have x greater than or equal 3 over 2. So this is the part A. Now, for part B, expand these linear factors, writing your answer as a polynomial in a simplest form. Okay, so expanding here, we will expand it. So we will multiply these two factors. So x times 2x is, we'll have 2x to the power of 2 minus 3x plus 12x minus 18. All of this multiplied by the factor 3x plus 20. This will give us 3x plus 20 times simplified 2x to the power of 2 minus 3x plus 12x plus 9x minus 18 equal. Now 3x times 2x equals 6x to the power of 2 plus 27x to the power of 2 minus 3x times minus 18, so minus 24 or minus 54x plus 20 times 2x squared 40x to the power of 2 plus 180x minus 0, 16, 360. Now we'll simplify it. So 6x to the power of 3, so 6x to the power of 3 plus 20x to the power of 2 plus 40x to the power of 2 plus 67x to the power of 2 minus 54x plus 180. So we have plus 120x minus 360. So f of x here equal 6x to the power of 3 plus 67x to the power of 2 plus 120x minus 360. So this is part B. Now for the part C, find the x-coordinate of P. The line L is a tangent to the curve at the point where C cuts the y-axis at x equal 0. So first of all, we need to find f of 0 because we need to know the y-intercept here to be able to write the straight line equation. So here we need to use the function that we have it here. So here we'll have to find f of 0 equal 0 plus 0 plus 0 minus 360. So f of 0 equal minus 360. So here f of 0 is minus 360, which is the y-intercept. So here we have minus 360 as y and 0x. This is the y-intercept point. Now, the slope of the tangent line at x equals 0, we need to evaluate f of prime of x. F of prime of x, we will use L power rule here to find the f prime. So f prime derivative of f of x equal 18x to the power of 2 plus 134x plus 126 Now also we need to find f prime at the point 0, which is equal to 126. Now here, because we found the slope at the tangent line and we found it 126, and already we have the y-intercept minus 360, so we can write the straight line L equation. Y equal slope 126x minus 360. Yes, this is the equation of the tangent line. Again, I will write here y equal 126x minus 360. Now we need to find the intersection point of L and C. This is the intersection point here, which is P, and we need to work it out. Working it out, it means f of x equal the equation of the straight line L. So here we need to have these two equations here. Now finding P, intersection of L and C, we have to make the curve C equal to the straight line. So here we have the equation, and equal to the here we have the equation of C, and here we have the equation of L. Simplify it, you will get 6x to the power of 3 plus 67x to the power of 2 equals 0. Take out x to the power of 2 as a highest common factor, so x to the power of 2 out. We'll have 6x plus 67, and this is equal 0. Then we'll have x equal minus 67 over 6. This is the value of x.